Okay, the next problem that we're going to do is going to be 21 over 35 divided by 3 over 14, which turns into 21 over 35 times 14 over 3. And I notice right away I can simplify this. 3 divided by 3 is 1. 21 divided by 3 is 7. So let me go ahead and multiply. 7 times 14 is 98. Use your calculator for that. And 1 times 35 is 35. And if you play with this long enough, you'll realize that 7 goes into both of these an equal number of times. 98 divided by 7 is 14. You can check that with your calculator. And 35 divided by 7 is 5. And so that would be the final answer, 14 over 5. Okay. Okay. Let's just continue on here and do a couple more of the division. 6 divided by 3 over 14. Well, this is just 6 over 1, which is 6 over 1 times 14 over 3, which is then equal to, and I can simplify this, 3 divided by 3 is 1, 6 divided by 3 is 2, 2 times 14 is 28, over 1 times 1 is 1, which is simply 28. And then finally, for the last one of this type, 42 over 30 divided by 7 over 1 is equal to 42 over 30 times 1 over 7. Notice I can simplify this. 7 goes into 7 one time. 7 goes into 42 6 times. 6 times 1 is 6. 1 times 30 is 30. And then I can simplify this. 6 goes into 6 one time, and 6 goes into 30 5 times. So the answer is 1/5. And that's a pretty decent primer, I think, on how to multiply and divide fractions. It's not that difficult, again. You just have to be patient with it. And the final thing that I want to do in this section is just do some composite problems where we're going to use all of these things at once, multiplication, division, etc. So let's do some. What we're going to do next is addition and subtraction. And again, there are different rules than multiplication and division. We're going to do a whole lot of problems and get the hang of it. So let's look at a few. 3/5 plus 3/5. Now, this is different than multiplication. The key to addition and subtraction in algebra, in math, is the bottom must be the same in order to add the top. You must find a way to get the bottom number to be the same. In this case, it's already done for us. Only after you do that can you actually add the fraction. Once the bottom number is the same, you just simply add the top number and retain the bottom number. So in this case, the bottom number is the same, so I can go ahead and add the top. 3 plus 3 is 6. I don't add the bottom number, I just keep it. 6 over 5. That's it. That's the answer. You just add the top, keep the bottom. Because really I'm adding portions of a 5. I'm adding 3/5 plus 3/5. So I've got to keep the same bottom number so that it is represented in terms of fifths. Let's just do more problems. I think it'll be clear. 4 over 13 minus 3 over 13. Again, the bottom number is the same. So I can just simply subtract the top. 4 minus 3 is 1, and I just keep the bottom number, which is 13. So it's very simple. Here it gets to be a little bit more interesting. What if you have something like 1/6 plus 1/24? Well, I cannot simply add these numbers. I can't make it 2 over whatever because these numbers are not the same. I cannot just simply add them like I was doing before. I need to figure out a way to make them the same on the bottom. And how can we do that? Well, earlier we said that you can change any fraction all you want day and night as long as you multiply or divide the top and the bottom by the same number. Only then can you start mucking around with the fraction. So let me say, if I wanted to change this fraction so that the bottom number was equal to 24 using multiplication, how would I do it? Well, as an example, let's say I multiply the top and the bottom of this fraction by 4. Well, 6 times 4 would be 24, and that would make the bottom the same, but then I would also have to multiply the top by 4, which would be 4. So let's do that. I got to pick a number I'm trying to equal, so 1 times 4 is 4. 6 times 4 is 24. All I've done is multiplied this fraction top and bottom by 4, essentially multiplying by 4 over 4, which I can do. I can do that all day long. It doesn't change this fraction. Plus, keep this fraction here the way it is, 1 over 24. The answer then is just add the top, 5 over 24. That's the answer. It's not great rocket science. It's just that you have to find a number that you can use to transform the fraction in the direction that you want to do. You're going to find in algebra that you're going to have a lot of latitude and a lot of freedom to do all kinds of cool stuff like that and to be creative. You just have to work with it. So let's take another. 3/5 plus 2/3. Now how am I going to do that? I gotta make both of these fractions have the same bottom number, and I can't transform them both so that the bottom has a 5 because I can't multiply 3 by anything that's going to be 5, and I certainly can't change this fraction so the bottom is a 3 because there's nothing I can multiply this fraction by to make the bottom a 3. So I've got to pick a new number. I've got to pick some other number to transform this fraction to. Well, let's just say, I'm going to write it out a little bit more explicitly. Let's say I take 3/5 and I multiply it by 3 over 3. I can do that. Okay, this part here, I'm going to use a parentheses. This is basically this fraction. I have changed nothing. I can multiply and divide by the same number all day long. That's the same thing on this side. 2/3. Let's say I multiply it by 5 over 5. As long as I do it to the top and the bottom, I can do it all day long, no problem. So let me go ahead and do this. 3 times 3 is 9. 5 times 3 is 15. Plus 2 times 5 is 10. 3 times 5 is 15. Now suddenly I have two new fractions that have the same bottom number. Now I'm good to go. 10 plus 9, 19 over 15. Done deal. You just have to find numbers to multiply these fractions by in order to get the same bottom number on both. Okay. Let's do another. Let's just keep plowing into these things. 9 over 4 minus 5 over 6. Immediately I notice 6 and 4, the common theme for me is 24. I mean, a lot of times when you're doing this, the number to shoot for in the bottom is simply going to be this times this. Because if I multiply them, whatever number I get, I'm always going to be able to make the bottom number in the fraction. So going on that assumption, trying to make the bottom equal 24, what do I need to multiply this fraction by so that the bottom is 24? I need to multiply by 6 over 6. Okay, so 9 over 4 times 6 over 6, that's equal to this fraction. I've changed nothing. Minus 5 over 6 times 4 over 4. Again, I've changed nothing, but now the bottom will be equal to 24. 9 times 6 is 54. 4 times 6 is 24. So I got my 24. 5 times 4 is 20. 6 times 4 again is 24. Now I'm good to go. I can subtract these things. And this is going to be equal to 54 minus 24 is 34 over 24. And because these are even numbers, I know that this can be simplified. They're both divisible by 2. 34 divided by 2 is 17. 24 divided by 2 is 12. And this is not able to be reduced anymore. And that's how I do that. Okay, let's take another. 7 over 10 minus 1 over 14. I need to find a bottom number here. It's not going to be 10 because I can't multiply this by anything that's going to make it equal to, correction, I'm sorry. I can't make this equal to any 14 on the bottom. There's nothing I can multiply this by to make it equal 14 on the bottom, and I certainly can't make this equal to 10. So I need to find something in the middle there. And it looks like you can choose a lot of numbers. You could choose 140 because that's 10 times 14, but in this case I've played around with it a little bit ahead of time, and I can transform it by doing this. 7 over 10, I can pick the number 70. How do I transform this bottom number to 70? Well, I can multiply by 7 over 7. That's totally legal to do, and that will make the bottom equal to 70. And if you play with your calculator, you'll see that if you multiply this fraction by 5 over 5, again, I've changed nothing fraction-wise, I've suddenly transformed this to 49 over 70 minus 5 over 70. That's 14 times 5 is 70. And that's going to equal 44 over 70, which is further reducible by dividing by 2. 44 divided by 2 is 22. 70 divided by 2 is 35. That's the final answer. You can't reduce that anymore that I'm aware of. Okay, and we're just going to do a few more problems in this section on fractions, and then they're going to deal with mixed numbers. It's just a different kind of fraction. It's not a big deal. It's not any harder than what we've done. Let's take a few examples. Sometimes you'll see fractions written as 4 and 3/5. And in this problem it's plus 3/5. Well, what does this mean? This fraction is less than 1. I've only got 3 parts out of 5. That's less than 1 part. 1 part would be 5 over 5. Here I have 4 and 3/5. So I've got 4 whole things, like 4 pencils, plus 3/5 of a pencil. So I've got 4 and some change there. And I want to add these together. Obviously it's going to be greater than 4, because I got 4 and some change and then some change, so it's going to be a number bigger than 4. Let's see exactly what it is. The easiest way to do this is to transform the fraction here as follows. How do you transform a mixed number like this? Well, the way you do it, because you really can't, you can do this problem multiple ways. I'm going to show you one way. I want to transform this number into a regular looking improper fraction. The way you do that is you take 5 times 4 is 20, and you add the top, which is 3. 23, write that down. 5 times 4 is 20, add the top. So you multiply here, you add here, you get 23. And then you just keep the bottom number 5. Okay? And then you just carry over the second part of the problem. Now you've got a fraction you can add. 23 plus 3 is 26 over 5. Now that's the answer. You can keep that as the answer, but if you want to convert this back to mixed fraction, all you have to do is say, well, how many times will 5 go into 26? Well, 5 times 4 is 20. 5 times 5 is 25. 5 times 6 is 30. And 30 is definitely greater. So this 5 can only go into 26 5 full times. So I write the 5 big out there like that. 5 times 5 is 25. And I've only got 1/5 left over because I equal 25. One more gives me 26, and then I just keep the bottom. So what I've done is I see how many times I can divide in, and a whole number of times, and I write that down. And whatever's left over, 5 times 5 is 25 in this case. 26 minus 25 is 1. I write that down, and then I keep the 5.